This is the first podcast on Chapter 13, and we're talking in Chapter 13 about experiments. But before you can understand what an experiment is, you have to understand what an observational study is. Okay? In an observational study, you don't assign choices or impose treatments. You're simply observing what's going on. Now, observational studies can be retrospective, where you take your sample and you look at data from that sample from the past. Or it can be prospective, where you collect your sample and then you watch them over a certain time period, like a certain number of years. Or it can be simply a survey, like we talked about in our last chapter. The important thing is that you're not causing any kind of a change, you're just observing. Now, because you're just observing, you can't imply causation. Even if you see that if this factor happens, then this frequently follows it. Even if you see things like that, you can't say that this causes that because you don't know if that's really where it came from. Okay, there could be a lurking variable. That's different from an experiment where you are assigning a choice or you are imposing a treatment. And because you're causing a change to happen, you can analyze how that change affects the thing you're studying or the people that are in the experiment. Okay? Theoretically, that's the only difference between your groups is that change. And so you can imply causation in an experiment. Let's talk about the 4 principles of experimental design. Okay, these have to be there for a good experiment to happen. 1, you have to have a control group, a group that you can compare with. Now, typically, it's nice to have a group that is doing things as it normally does. Okay, so you can see how the other treatments are different from what normally happens. Okay, that's the control group. The second principle is using randomization. Okay, so you have to randomly assign the participants into groups. If they're allowed to choose which group they're in, that could cause some bias and cause some uncontrollable or unknown sources of variation. So you randomly assign the participants into treatment groups. Okay, the third is replication. You have to replicate it over several people, several groups of people, several types of people. The more that you replicate it, the more you're able to zero in on the variable that or the change that you're causing, as opposed to there could be a difference between your 2 groups that you're unable to see, another lurking variable. Okay, now before we talk about block, let me show you a diagram. Okay, and these are helpful to see what an experiment is. So you have your random allocation, you have your 2 groups, and again, I've eliminated treatment 2 to emphasize that you need a control group that you can see what happens normally to see how that's different from your treatment, and then you compare the results from the 2 of them. Okay, this is a very simple experiment. There isn't any blocking in this. So let's go back. The 4th principle is blocking. Sometimes there are attributes of your experimental units that you can't control, but may affect the experiment. Okay, in that case, you'll want to block your experiment. So, for example, if you're studying TV watching, or how many times students check Facebook, okay, and you think that there's a difference between students who live on base versus off base. Okay, you may want to block your experiment to students that are on base and off base, and then randomly assign treatments within each of those groups. Okay, or if you read in your textbook, there's an example about tomato plants from 2 different stores that we don't know if there's a difference between tomato plants from store A or store B, and so we block them, and then within each block, or within the plants from each store, you then assign them to the 3 treatments. Okay, that's blocking, and it's useful whenever you think there might be a difference in your population or your sample that could affect your treatments and your whole study. Okay, the last idea about experiments that I want to bring up is the idea of blinding. When either the individuals that are in the study or those who are giving some kind of a treatment don't know which group the person is in, it's called single blind. Okay, and there could be if for example in medical research, if you as someone who's giving treatment knows if the person's in the control group receiving what's called a placebo or a pill without the medicine in it, as opposed to a person who's receiving the pill with the medicine in it, you may treat them differently, and therefore it's important to blind your experiment. Okay, when both the person in this receiving the treatment and those giving the treatment, when they both don't know who's in which treatment group, it's called double blind, and that happens sometimes. Okay, those are some of the important ideas about designing an experiment.